The Smooth Way universe and Andromeda universe are drawing nearer together every minute consistently, and in the end, they will blend. The Andromeda world, M31, and the Smooth Way cosmic system, two of the biggest worlds in the nearby bunch, are on an impact course that will unfurl over billions of years. While many consider cosmic crashes disastrous blasts, they are actually undeniably more elegant, like a sluggish motion dance that stretches throughout enormous timescales. Proof shows that this crash has proactively started. As these two cosmic systems approach each other, their gravitational forces are starting to reshape the two frameworks, starting changes that will have extensive impacts on the stars, gas, and other vast parts. When you contemplate the universe, imagining galaxies is easy, moving farther apart due to the development of space. After all, that's what the Hubble Space Telescope has shown. Systems subsiding from one another as far-off systems seem to move toward the red end of the range, a phenomenon called redshift. Anyway, the Smooth Way and Andromeda are part of a remarkable circumstance. These two systems are relatively close to each other, only around 2.7 million light-years apart, so the universe's development doesn't influence them in the same way. The power of their common gravitational attraction is far stronger than the development of space at such a short proximity. Gravity, the central force that governs large-scale movement, pulls them toward one another at a stunning velocity of 123 kilometers per second, around 76 miles per second. This quick development is making way for a cosmic consolidation that will totally reshape both systems. While such a crash may sound like a fierce disaster, the real interaction is significantly more progressive and agile. As worlds are mostly made up of void space, the actual stars are unlikely to crash. Rather, it's the gas, residue, and dark matter that will interact, leading to shocking new arrangements and enormous phenomena. One of the first signs that the Smooth Way and Andromeda have begun cooperating is the discovery of hypervelocity stars. These stars are moving at fantastic rates, up to 1,000 kilometers per second, quick enough to escape the gravitational pull of their home cosmic system altogether. But how do these stars reach such high speeds? A few systems can make stars reach these enormous paces in binary star systems, especially near really enormous black holes. A binary star system is when two stars orbit around a common center of mass. If such a system gets too close to a supermassive black hole, the gravitational forces can disrupt their orbits. One star might be pulled into the black hole while the other is ejected at a speed so high that it escapes the system's gravitational hold. This interaction, known as slingshotting, can drive a star to hypervelocity speeds. Furthermore, when cosmic systems impact or pass close to one another, their gravitational forces can eject stars from their homes, particularly in dense regions where stars are closely packed. The cooperation between universes, specifically the gravitational forces at play, can disrupt the movement of stars, pushing some of them out of their home systems completely. Stargazers believe that many hypervelocity stars in the Smooth Way have been ejected from Andromeda in this way. Simulations and data from missions like Gaia, which is mapping the positions and speeds of stars in our system, support the idea that Andromeda's gravitational impact is already starting to reshape the Smooth Way's stellar population. As cosmologists continue to search for these fast explorers, they uncover more evidence that the Andromeda Smooth Way cooperation is well underway. In addition to hypervelocity stars, cosmologists have found another piece of evidence that the systems are connecting: the crash of their cosmic coronas. A universe's corona is an imperceptible, diffuse region of gas, dust, and dark matter that surrounds it, extending far beyond the visible stars. Coronas don't emit light, but they have mass and are crucial in the dynamics of cosmic system formation and development. The Andromeda Galaxy's corona is especially large, extending over 1.3 million light-years toward the Smooth Way and up to 2 million light-years in some directions. Despite being invisible to the naked eye, the gas and dark matter in the coronas still have significant gravitational impacts on the systems themselves. In pivotal analysis, astronomers using the Hubble Space Telescope studied the light from quasars located behind Andromeda's corona. Quasars are extremely luminous objects powered by supermassive black holes at the centers of distant galaxies. As the light from these quasars passes through Andromeda's corona, it is absorbed by the gas and dust, revealing detailed information about its composition and structure. What astronomers discovered is surprising. Andromeda's corona is so vast that it overlaps with the Smoothways corona. This crossover shows that the two universes are already in the early stages of a cosmic crash. While the stars within the systems are still mostly separated, their gas and dark matter coronas are beginning to connect, marking the start of a slow and long-term merger. This discovery adds further evidence to the idea that the Smoothway and Andromeda are already engaged in a cosmic dance that will shape their futures for billions of years. The emotional impacts of the Andromeda-Smoothway merger will unfold over billions of years, beginning with an initial close encounter around 3.75 billion years from now. As the two systems pass through each other, their gravitational forces will cause their shapes to distort, triggering massive bursts of star formation as gas clouds collapse under intense pressure. This period of rapid star birth will likely be accompanied by the formation of new stellar clusters and even some stellar remnants, like neutron stars or black holes. As the two galaxies continue their slow-motion collision, the night sky will become a stunning display. Andromeda, which is already visible from Earth as a faint smudge in the night sky, will gradually grow larger, spreading across the sky for hundreds of millennia. As it draws nearer, the two galaxies will eventually merge, but their common gravitational attraction will pull them back together for a final catastrophic impact about 4.5 billion years from now. This final merger will likely result in the formation of a new, larger elliptical galaxy, often referred to as Mila. At the heart of this new galaxy, the supermassive black holes of the Smoothway and Andromeda will merge, forming an even more powerful black hole. The stars and gas in the two galaxies will be reconfigured into an entirely new structure, possibly leading to the creation of new star systems or the ejection of some stars into intergalactic space. As for our solar system, its fate remains uncertain. It could be flung into the outer regions of the new elliptical galaxy or even shot out into the vast void of intergalactic space. However, this dramatic scenario will unfold long after humanity's time on Earth has passed. Future generations of humans or life forms that may evolve from us could witness the dramatic changes in the night sky. The possible merger of the Andromeda Galaxy and the Smoothway is one of the most awe-inspiring events in the universe's future. Though this vast crash will take billions of years to fully unfold, it is already in progress as evidenced by hypervelocity stars and the overlapping coronas of the two galaxies. While the immediate results may seem distant, the actual process is a testament to the dynamic and ever-changing nature of the universe. As galaxies collide, merge, and evolve, they shape the universe in profound ways, reminding us that the universe is anything but static. It is a living, breathing entity, constantly changing and advancing. The merger of the Smoothway and Andromeda will forever change the night sky, and it is just one of the countless cosmic events that highlight the glorious and boundless nature of the universe. As the Smoothway and Andromeda continue to move toward one another, their interaction will not only reshape their structures, but also have sweeping implications for the galaxies within their spheres of influence. Over the course of billions of years, this cosmic dance will alter the position, movement, and nature of stars, gas, and dark matter in ways that we can begin to understand. It is important to note that the process of cosmic mergers is not a fast or short-term event. Rather, it is a series of carefully coordinated cosmic scenarios, each unfolding over enormous timescales, allowing us to study the galaxies involved, even from our vantage point on Earth. One of the key aspects of this infinite crash will be the transformation of the stars that are part of the two merging galaxies. Throughout the merger process, the two galaxies will experience bursts of star formation. These explosions will be fueled primarily by gas and dust colliding and compressing as the galaxies pass through one another. When gas clouds crash at high velocities, the intense pressure and heat cause the gas to collapse, leading to the birth of new stars. This rapid star formation will create an entirely new generation of stars, some of which will be massive and short-lived, ending their lives as supernovae. These explosive events will scatter heavy elements like iron, calcium, and oxygen throughout the merging galaxies, enriching the interstellar medium and providing the building blocks for future generations of stars, planets, and possibly even life. In addition to the creation of new stars, the merger of the Smoothway and Andromeda will also likely lead to the disruption of existing stellar systems. The gravitational forces at play during the impact will pull stars out of their orbits, either ejecting them into intergalactic space or altering their paths within the galaxy. Some stars may even be captured by the very massive black hole that will form at the center of the new merged galaxy. This chaotic environment will make it more challenging for planetary systems to remain intact, as gravitational disturbances could dislodge or destabilize the orbits of any planets present at the time. Another fascinating aspect of this cosmic merger is the potential for the formation of new stellar remnants. As the galaxies collide, massive stars will burn through their fuel more quickly, leading to the creation of neutron stars or black holes. These dense, compact objects will add to the complex gravitational landscape of the new galaxy. Some of these black holes could merge to form even more powerful gravitational sources, potentially emitting gravitational waves that might be detected by future generations of space scientists. The formation of these new stellar remnants will further enrich the composition of the merging galaxies, influencing everything from the movement of stars to the formation of future stellar clusters. The intergalactic space between the Smoothway and Andromeda will also play an interesting role in the merger. As the two galaxies collide, the space between them will be filled with a turbulent mixture of gas, dust, and dark matter. This region, though largely invisible to the naked eye, will experience an increase in activity as gas clouds are compressed and heated, potentially leading to the formation of new, smaller galaxies or the acceleration of cosmic phenomena like supernovae. The intense radiation and energetic events occurring in this vast region of space will further fuel the astronomical cycle of birth, death, and rebirth that is fundamental to the universe's ever-changing nature. The fate of the gas and dust in the intergalactic medium is also of great interest to astronomers. As these materials are drawn into the gravitational wells of the merging galaxies, they will contribute to the transformation of the cosmic conditions. The gases will be funneled into the supermassive black holes at the centers of the galaxies, potentially fueling the formation of active galactic nuclei or quasars. These brilliant objects, powered by the immense gravitational energy from the black holes, will shine brightly across the universe, providing astronomers with valuable insights into the inner workings of cosmic mergers and black hole formation. The crash between the Smoothway and Andromeda will also have implications for the larger cosmic structure they are part of. The nearby galaxy group, which includes both the Smoothway and Andromeda, is currently part of a larger cosmic web of galaxy clusters and superclusters. The merger of the Smoothway and Andromeda could influence the dynamics of other nearby galaxies, potentially leading to the reshuffling of galaxy groups or even the creation of new galaxy clusters. As galaxies merge and interact in these vast environments, they help shape the structure of the universe on the largest scales, providing key insights into the nature of dark matter, dark energy, and the expansion of the universe itself. In the long run, the merger will result in a massive elliptical galaxy that is destined to be vastly different from the spiral galaxies we know today. The new galaxy, often referred to as Mila, will be a completely reorganized entity, with an entirely new arrangement of stars, gas, and dark matter. This new galaxy will likely have a much more spherical shape than the current spiral designs of the Smoothway and Andromeda. The end of the merger process will mark the climax of billions of years of cosmic evolution, but it will also raise new questions about the future of the universe. While the merger of the Smoothway and Andromeda is still millions of years away, the process offers a fascinating glimpse into the dynamic, ever-changing nature of the universe. It highlights how galaxies are not static entities but are constantly evolving through interactions with one another. These cosmic mergers contribute to the ongoing reshaping of the universe, resulting in the birth of new stars, the formation of new cosmic structures, and the continuous transformation of the astronomical landscape. The eventual merger of these two galaxies serves as a reminder of the vastness of reality in the universe, offering a humbling perspective on the lifespan of our own galaxy and the Earth itself. For now, we can marvel at the distant future of the Smoothway and Andromeda, knowing that we are living in a fleeting moment in the immense and ever-changing universe. As the Smoothway and Andromeda continue their cosmic dance toward merger, the interaction will extend far beyond the two galaxies themselves. The massive gravitational forces exerted during the impact will likely cause distortions in the surrounding cosmic environment, including the influence on neighboring galaxy groups. The impact may trigger a surge of events, including the acceleration of other galaxies in the local group, potentially altering their trajectories as they are drawn.